Okay, so I just made a 10-minute video that got deleted, but that's okay. I'm not going to let that stop me. I'm going to go over a couple of topics related to proteins that are translated at the ER. So, here we have a ribosome that's already been assembled. It's already associated with the mRNA. If you need to, you should go and review the steps that lead to the initiation of translation and the assembly of the ribosome. Here we have some of the mRNA already having been read. That portion of the mRNA has coded for an ER signal sequence. So remember that the signal sequences are just patterns of amino acids. So that's what's shown here. So this is similar to the illustration in your book. It showed a little bit of the new peptide sticking out of the ribosome. The peptide consists of a chain of amino acids. And remember that the N terminus of the peptide chain is always translated first. So we know that the ER signal sequence is always at the N terminus of a protein. Go back to the slides from Monday to see an example of that, or you could go to your book and look at the chart that has the actual amino acid sequences of the signal sequences. And so you'll see that the signal sequence for the ER has an N terminus on it because the ER signal sequence in a protein is always translated first before the rest of the protein. Okay, moving on. Once this is translated, then another protein, which we didn't discuss in class, so you don't need to know this, but just for your own background, another protein comes and recognizes this localization signal. This is the signal recognition peptide. It is mentioned in your textbook. All you need to know for the exam is that we translate this localization signal and then something happens to move this entire complex to the ER. Now, if it helps you to know that the signal recognition particle recognizes the sequence and is responsible for moving this entire complex to the ER, then that's fine. Moving on to the next step. Again, we have this entire localization sequence for the ER. Yes, it's the same as this thing. Pretend that it is the same length. I'm not perfect. It's Friday afternoon. So this ER localization signal is going to be bound by this protein, this cylindrical protein, which is a translocator protein, or it's basically a channel protein. So it's a protein that's in the membrane of the ER, and it has an area in the middle where amino acid chains can flow through. So it binds to this localization signal and holds it there in the translocator protein, which is in the membrane. Now, this signal sequence is going to remain connected to the rest of the peptide chain that is being translated. Once the ribosome gets to the ER, it continues translating this mRNA. So we could see that it's translated, it's just read more of the mRNA at this point, and so it's translated more of the sequence. This is connected to the ER localization signal, and the rest of the peptide is threaded through this localization protein, or protein translocator. Two ways of saying the same thing. And you'll see that some of the amino acid chain now is going to be inside the ER lumen. So what happens after this? What happens when this mRNA is completely read and is completely translated by the ribosome? That's what we have in the next step here. So in this case, this is one scenario right here where the ribosome is done, it's dissociated. You can see that this is a lame dissociated ribosome, but that's okay. And then the mRNA is here too. And of course, we could reuse this mRNA and translate another protein that will also be assembled at the ER. But for this protein that we saw the beginning of the translation for, the ER localization signal is cut off, so this peptide bond is broken. So that would be, going back to this image, the peptide bond over here is broken, so that only this peptide